Hello everyone, my name is Chang. I'm CST2409039, and here I'm talking about the derivatives to the economics first. Derivatives are essential tools in economics for analyzing the behavior of functions that describe cost, revenue, and profit. These functions are key to understanding a firm's performance and decision-making processes. The cost function, Cx, represents the total cost incurred by a firm to produce X unit of output. This function includes both fixed costs, which don't change with the level of output, and variable costs. It changes with the level of output. Yeah, the derivative of the cost function gives the marginal cost, which is the additional cost incurred from producing one more unit of output. It is a key measure for firms in decision making because it helps them determine the cost impact of increasing production by one unit. The revenue function, Rx, represents the total revenue a firm earns from selling X units of output. It is typically the product of the price per unit and the quantity of units sold. The derivative of the revenue function gives the marginal revenue, which is the additional revenue gained from selling one more unit of output. And let's talk about this application. Firms use marginal revenue to help determine the optimal quantity of output to produce. If marginal revenue is greater than marginal cost, increasing output will increase profit. If marginal revenue is less than marginal cost, producing more will decrease profit. Two derivatives of the profit function gives the marginal profit, and when a marginal profit of a firm is negative, it means that the firm should decrease output. And the average function is the functions divided by x. The derivatives of them demonstrate the rate of change of each function with respect to output. These functions help to understand the cost and revenue per unit of output and are typically used to assess production efficiently and profitability. Through derivatives, firms can identify the optimal production level where profit is maximized or cost is minimized. By analyzing these functions through derivatives, firms can make more informed decisions regarding pricing, production, and overall strategy. Okay, then let's talk about the Washer method. The Washer method is a technique to calculate the volume of a solid of revolution, particularly when the solid has a hollow or washer-like structure. It is a variation of the disk method, and it is used when there is a gap between two curves. One curve is inside the other, and it is being revolved around an axis. When we use Washer method, firstly, we need to visualize the solid of revolution and then set up the integral. At last, we use the volume formula. Just put numbers in it. Here is an example. The outer curve is x and the inner curve is x squared. So we can find the inner and the outer radius easily. So just put the number into the formula, then we can get the result. Yeah, this is the formula. Okay, at last, we talk about the moment and the center of mass. Firstly, the moment of mass. It is also called the moment of inertial. Its definition is the moment refers to the measure of the tendency of a force or mass to cause rotation about a point or axis. In simple terms, the moment is a measure of how much a force or mass wants to rotate the body about an axis. And there are two main types of moments. First one is moment of force. This measures the rotation effect of a force around a specific point. The second one is point of mass. This measures how mass is distributed relative to an axis of rotation. It is used to describe how difficult it is to rotate a body around a given axis. And the moment of I for a point, mass m at a distance r from a pivot point is given by this formula. And I, it means moment of inertia. M means that mass of the object, and r means that distance from the axis of rotation. And for a rigid body with a continuous mass distribution, the moment of inertia is calculated by integrating over the entire body. And in this formula, the r means that the perpendicular distance from the axis of rotation to a differential mass element dm. And let's see the center of mass. The definition is that the center of mass is the point in a body or system where the mass is considered to be concentrated. For a uniform object, the center of mass is typically located at the geometric center. However, for an object with uneven mass distribution, the center of mass is shifted towards the denser regions. For calculate a center of mass in a system of particles, typically we just calculate them together, and we can get the point by use the arithmetic average. And here is an example. We give 3 points A, B, C, and we calculate the center of mass. Just like the formula before, this one. We just calculate them together, plus them together, and then to get the average of them. So we can easily get the center of mass, point G, by use the arithmetic average. That's all. Thank you.